Good morning and welcome to another session on Information System Audit Series. And today I'll be talking about digital signature, which is covered in the module 5 of the Information System Audit course. So in this series, this will be the fourth and the last part of the module 5, and I hope you'll find the video useful. What is digital signature basically, if you are going to talk today? And this is a very important section, and you will find invariably one or two questions coming directly from digital signature. Now, digital signature is nothing but it's a process of attaching a digital code, we call it as hash, to an electronically transmitted document so that the content of the documents as well as the sender identity can be verified. Now, this is a slightly technical, but I'll try to explain you all the technicalities so that you understand what exactly digital signature is. Most of the chartered accountants are using digital signature for sending the office documents officially, right? Be it income tax or with the other purposes. Now, why we use digital signature? The importance of using digital signature is that firstly, it ensures that and verifies the integrity of the message. Integrity means that during the transit of electronic document, nobody has changed anything or the message has not been tampered. Second, it also ensures the authentication, that is, message has actually been sent by the sender. So these are the two important aspects for which digital signature is used. First, that the sender who's sending the document on an electronic document to the receiver, this gives a confirmation to the receiver that the document during the transit has not been changed or altered. Secondly, this is being sent by the person who is very, very genuine. Authentication as also can be put it in terms of non-repudiation, which means the sender cannot deny about sending the message. Oftenly, you might have seen that, they say that sometime I have sent it by mistake or I have not sent this message. But when you use a digital signature, then you cannot back it out by saying that this was not sent by you. So digital signature primarily, if you look into it, ensures the integrity of the document. That is, the contents are original. And the second, it also authenticates the person who is sending the document across the network. Now, the important aspect which the questions on which, based on which the questions are framed in the ICAI exams, is that about the confidentiality. Now, please remember, when we talk about the integrity, we are saying that the contents are not altered or tampered. But nowhere, or we can say that during the transit, nobody has seen the document. That talks about the confidentiality. That means that digital signature, if you're signing an electronic document using digital signature, it definitely ensures the integrity and the authentication of the sender, but it does not ensure any type of confidentiality, which means that it doesn't say that while the data is traveling across the network, nobody has seen it. Very likely the chances are there, people might have seen it, but they have not altered the content. This is being verified and ensured in terms of document integrity by the use of digital signature. A digital signature verifies the authenticity of the digital message or the document. Now let's see technical aspect of digital signature. So what happens exactly? I mean, when you are signing your document with using digital signature, you're basically using a hash algorithm. What exactly it does is it tries to generate a hash of the message. That is, it involves basically two steps. First is hash or the message digest, they call it, of the message is created, which means your original message remains intact. The way you have written the message, it is very, very, the generation of hash function or use of hash function or the message digest is very, very sensitive to the original content. On the basis of the original content, I will use hash algorithm to generate a hash or a message digest. Now, this hash and a message digest is then encrypted using the private key of the sender. Now, look into it first. When in the first step, I'm encrypting, I'm encrypting a message integrital issues I'm trying to concern, right? When I say I'm generating hash or a message digest, in that case, I'm saying I am not concerned what the message is all about, but the way message has been written or drafted based on that original content using hash algorithm, a message digest is generated, which is a string of fixed characters. Now, you can see that when the this first step, when you are generating the hash message, you see the result which is coming out in the form of an numbers, alphanumeric, string of fixed length. Now, this is basically the digital signature. Now, this digital signature is then encrypted using the private key of the sender. Now, private key of the sender ensures that it is the non-repudiation as well as the authentication of the person who is sending the message. So this is, again, now, as we have discussed so far, nowhere digital signature ensures the confidentiality. And it is quite obvious because hash function or the message digest is not concerned with generating or decoding the message itself. It is trying to understand the formatting, layout, and the sensitivity of the message. Based on that, using hash algorithm, it will generate a fixed string of characters. And this fixed string of characters or a message digest is then encrypted using the private key of the sender for the authentication purposes, right? I'll explain you further. So as a hash function, as I have discussed, is a mathematical algorithm which gives a unique fixed string to any message, and hash value is unique for each message. Now, this is a very important aspect if I wanted to stress upon. Now, as I have said that when I'm writing a message, which I wanted to send using digital signature, now there will be certain letters which are in uppercase, smaller case, full stop, spaces. Once I have done with the message, and then if I use hash function, it will be generated based upon all the factors which I have used, like uppercase, lowercase, case sensitivity, spaces, full stop. If any person who later on tampers this message or changes any content in the message, then the hash functions automatically gets changed. Now you can see how it works. I am sending a message using hash function. So I have written a message. I'm signing it with a digital signature by generating a hash or a message digest, which I am sending it, which I'm encrypting it and sending it to the person whom I intend to. In between, say Mr. X is there who got access to this message. He played around with the figures in the message itself. And when he tries to, the moment he plays around with the figures, the hash functions which will be generated by that algorithm will now be the different from the original one which I have sent. So when the receiver receives the message with the digital signature, and when he tries to decrypt it, he'll find that my hash or message digest is not matching with the hash or the message digest which he has generated when he receives the message. This clearly indicates that the message in between or during the transit has been altered or tampered. Digital signature encrypts the hash of the message and not the message. Let's be very clear. This is the reason, that is why we are talking about that digital signature at no point of time ensures that the message has not been seen by anybody else. So if you talk about that, suppose if the question is there, that digital signature ensures confidentiality, no, it does not ensure confidentiality as well as the privacy. Private key of the sender is used for encrypting the hash of the message. Now, when I say private key of the senders, this gives you this just generates the authentication of the sender, that who is the sender, because only sender has a private key which he is using for signing the document digitally. Non-repudiation provides the strongest evidence that a specific transaction or an action has occurred, and no one can deny about those transactions. The non-repudiation is a strong word. I mean, you should remember, because whenever you are talking about digital signature, you must remember the words integrity, confidentiality, privacy. You're talking about authentication and non-repudiation. Now, digital signature is is based on cryptography. Now, cryptography is a technique of coding and decoding the message, right? So without going into much of technical detail, I'll just share with you what is encryption and what is decryption. Encryption, we have just used about this word when I said that the message digest which is generated using hash algorithm or a hash function is encrypted by the private key of the sender. Now, when I say encrypted, that means I have encoded the entire thing using my private key. Now, this is only possible when I am using the cryptographic, and digital signature is based on cryptography, right? So when the receiver receives my message, I mean, then what he does is he uses the public key and then he decrypts the message and he has access to the message which I have sent it across the digital network. So public cryptography is a method of encrypting or signing data with two different keys, that is public key and the private key. Public key is available to anyone for use. As I said, data encrypted with the public key can only be decrypted with the private key. Now, if you are encrypting a data with using the, or if you're encrypting message using the public key, then you require a private key for decrypting it. If you're encrypting with the private key, you require a public key for decrypting the message. Now, these are again, I'm extending my explanation so that in case if the question is being asked, you should remember, you'll be able to answer it. Asymmetric encryption, obviously the name itself asymmetric in the sense you require, it is not the person who is encoding and the person who is receiving will have to use different sets of keys for reading the message, which is asymmetric, right? That is a public key and a private key. Then it makes use of two keys, hence it will be slower and it is slightly expensive. When I talk about the symmetric encryption, in this case, you are using only one key for encrypting and decrypting it. And as a result, this will be faster and it will be inexpensive. Again, I repeat the last two sentences because I feel that they are very important. Confidentiality of the message is ensured by encrypting the message using the receiver's public key. Always remember. Now, if you are using digital signature, you're generating hash or a message digest of the message for the message using hash algorithm, and then you are encrypting it with the sender's private key and sending it across the network. This will not ensure the confidentiality. But in case if you want to ensure that nobody reads the message during the transit, then you should also encrypt the message using the receiver's public key. That is, the person who is going to receive his public key should be used for encrypting the message itself. In digital signature, as of now, we are encrypting the hash or the message digest. But if you wanted to have confidentiality features added to it, then it is essential to encrypt the message using the receiver's public key. Authentication and integrity of the message is ensured by creating the hash of the message, also known as message digest. I have spoken about it. Now look at it. This will give you a clear idea as to what I was talking about. Suppose if you are the signer and this is a document, you have generally used the hash algorithm and you got the hash function for it, which is again a fixed string of alphanumeric. Then you use private key and encrypt this hash function. You are not encrypting the message. Now you have finally signed your document digitally using the digital signature. It travels across the network. Now, digitally signed document at the receiver end. Now you find that because here when you are receiving it, you need to decrypt it. So the person who is receiving it uses public key and he tries to decrypt it. When he decrypts, he gets the hash of the message, which he compares with the hash which I have generated when I was encrypting the message. If these two hashes are the same, it clearly means that the message has not been altered during the transit. But if this hash which I have generated when I was encrypting the message differs from the hash which the verifier or the user generates at the receiving end, this clearly means that during the transit, the message has been altered or changed. Confidentiality of the message is ensured. Again, I'm repeating it again and again in my slide so that you remember. The confidentiality, if you wanted to ensure, then please encrypt the message using the public key of the receiver. For ensuring confidentiality, authentication, and integrity of the message, you have to follow the two steps. First is you have to encrypt the hash or the message digest of the message, right? You're not encrypting the message, but you are encrypting the hash or the message function, which you have generated using the hash algorithm, which you will be sending it to the sender using the private key. Now, this will ensure authentication and non-repudiation and the integrity. But to ensure confidentiality of the message, you have to encrypt the entire message using receiver's public key. Now, this will ensure confidentiality. I once again want to repeat and make it clear. When you are using digital signature, then what exactly you are doing is you are using hash algorithm for generating the hash or the hash function of the message which you wanted to send across the network. This message digest or the hash value which you have generated using hash algorithm is encrypted using the sender's private key. If I am sending, I will use my private key for encrypting this message, hash message or the message digest. Now, this will only ensure the non-repudiation, integrity, and confidentiality is not ensured by doing this process. But if I wanted to add confidentiality of the document, then what I should do is I should encrypt the message which I am sending. Besides hash value and the message digest, I should also encrypt the message, but this time I should use public key of the person who is going to receive the message. By doing so, I am now ensuring confidentiality, authentication, as well as integrity of the message. Now we move on to the another important concept which there in the module 5, it talks about the biometrics, that is using human attributes for identification and verification. Now, biometrics refers to the metric based on human characteristics or attributes. Now, like say, for instance, my voice, my fingerprints, my retina scan, my DNA, my hair strand, all these type of things are considered as a part of the biometrics. Biometric verification is based on unique identification of an individual. You must have watched some English movies and you will find, as well as now in India also, almost every organization is using biometrics for marking their attendance or their presence. Biometric evaluates biological features, as I have mentioned, such as fingerprints, retina scan, iris pattern, voice, DNA, just to name a few. Now, why biometrics? We are going to talk about it because if you look into the biometric solutions, their accuracy measures, which normally the standards are used in biometrics, is false acceptance rate and the false rejection rate. Now, these are quite complicated, but if you understand clearly, clearly, you will find that it's very simple. Now, false acceptance rates name itself says that the system accepts people who are not authorized. And false rejection rate means people who are authorized are being rejected. Now, what happens in biometrics? For a particular attribute, like say for a retina scan of a fingerprints, the users are registered first with their impressions or the imprints. That creates a database. Now, when a person further wants to access a particular facility, he or she uses the biometric imprints on the scanning device. Now, this device scans and finds it out from the database library. And from that library, it finds out what are the areas to which this person is authorized to. And based on that, rules and regulations, the permission is given or permission is denied. Because it is done by the machine, the chances are there that sometimes it so happens that there is a false acceptance rate, which means the system which is working as a biometric for giving access to the people by mistake or turns out to be defaulting, and it starts giving more acceptance to the people who are not authorized. That is considered to be the false acceptance rate, that is FAR. That's a major concern for this biometrics. On the other hand, at times it may also do what you call it as a false rejection rate, which means that the people who have been authorized to are not given the permission and are denied. And the third one is cross error rate, which is equal error rate. That is when you find that the false rejection rate and the false acceptance rates are equal. We'll talk about it more. Now, both false acceptance rate and false rejection rate are inversely proportional to each other, which is quite obvious. If you find that the false acceptance rate decreases, I mean, it is going down, that means system is working properly and it is not giving access to the people who are not registered. So then in that case, you will find that the false rejection rate will definitely be higher, which means that now the system, because system is giving access to the people who are not registered, so obviously system will be denying access to the people who are being authorized and registered. Similarly, on the other hand, if you find that the false rejection rate is decreasing, which means the system is accurately considering the request of the people who are registered and it's allowing them access, and it is denying access to the people who are not authorized, then you will find that the false rejection rate decreases and the false acceptance rate increases. So for at this point of time, the one point which I wanted you to remember, that both FAR and FRR are inversely proportional, which means that if FAR is increasing, then FRR should decrease. And if FRR is decreasing, FAR should increase. A point where FAR is exactly equal to FRR, then it is known as cross error rate or CER. False acceptance rate, that is, I mean, we've already talked about it. So retina scan has the highest reliability and the lowest false acceptance rate among the current biometric method, but it is slightly expensive where you use your retina scan. And because normal biometric, indicators, like say, for instance, my voice, my fingerprints, they may change over a period of time because, for example, my voice, if I'm having a cold, it may change. So the FAR false acceptance rate will be very, very high, or maybe it is low. So, but in retina scan, you will find that because it normally do not change, so it has the highest reliability as far as false acceptance rate is concerned, which means that the unauthorized persons will not be allowed or given the access. We now move ahead with another important aspect of intrusion detection system, that is IDS, and intrusion prevention system, that is IPS. Before I move on into it, let's understand the meaning of intrusion. Intruder means any person who is an outsider, a person who is not has the privilege to access, a person who has not been given the rights to access, but he somehow gets into the system or get access to the facility or get access to the premises or get access to the system. So there are two words are there. One is intrusion detection. This is a preventive control measure. This will not do anything, but it will only help in detecting that some intruding activity is taking place in the network or at the system level. Whereas intrusion prevention system, IPS, will definitely be there. It will detect, but it will also suggest or take some preventive action. That is, these are the systems which can take care, or they can learn from the earlier mistakes, that what in type of an intrusion activity has happened and how it can be rectified. I'll explain it later on as we move ahead. So intrusion detection system is a device or a software application that monitors the network, that is network-based IDs, and the monitor system, that is host-based IDs. As I have discussed, you can, because normally we are working in a network environment, so I can implement an intrusion detection system, which can be a device or it can be a software application, just like you have seen it's a firewall that monitors means what traffic is coming into my network is being monitored very carefully. And then this network based intrusion detection system alert generates the red flags. Red flags means they will tell about the traffic which is very, very doubtful and dubious. This can also be happen or can be done at the host level, that is the system based level. Types of intrusion detection system, if you see from the examination point of view, it can be three: signature, statistics, and neural network. Now, intrusion detection system, when you talk about the signature, I wanted to explain you with the help of an example. Like, for example, our immune system. So many times you find that you have a viral fever or something. So our body's immune system starts fighting with those foreign bodies, and they provide the control measures, and we get relief from the system. That's how our immune system works. Same way, this type of intrusion detection system, which is signature based, identifies the types and patterns of attack on a network or on the host of the system, and it keeps a record of it, what type of attack or the patterns of attack or dubious activities it is happening on the network or on the host level or the system level. Now, these patterns and types of intrusions are stored in the form of a signature. Just like whenever we get an attack, we have a viral fever, right? So our immune system takes a snapshot or imprints and keep a track of it, that when this type of an infection happen in the body, these type of antibodies are released into the blood so that they fight and the body gets cured. But it also keep a track of it. So next time when I get the same type of an infection or any foreign body enters into my body, then my immune system triggers only those antibodies which are required for fighting with that particular type of a disease. Same happens here in signature. Signature intrusion detection system is also known as a rule-based intrusion detection system. So always remember, when you're talking about the signature means you are having imprints of the intruding activities, which the system keeps track of it, and based on that, it develops the red flags. Now, statistical intrusion detection systems can determine the normal and expected behavior of the system, and any activity falling outside the scope of the normal behavior is flagged as intrusion. Now, again, when you're talking about the statistical, you're talking about that, there are certain knowns and knowns rules expected. Now, we've defined what type of a traffic we are going to expect, but anything which is coming, for example, if you are getting a repeated request from a particular IP address, that is Internet Protocol address, and which is not clear as to what type of a system is trying to access to your network. So this means it's just unknown. So this statistical intrusion detection system will understand that this is not the normal behavior and would accordingly consider it to be an intrusion. Now, third one is interesting. That's a neural network. Now, similar to statistical ID, with added functionality of self-learning. As I have said in case of signature, you must have seen that our body learns how to fight or generate antibodies for anything which is harming our body, right? So neural networks are like that. They are self-learning, that they will find if they're finding an intrusion activity, they will see to it that what best mechanism can be done to avoid it, and they will keep an imprint onto it, and they'll keep on learning from what type of activities happen and what were the key learnings from that particular activity, right? So only neural network creates its own database and is more effective in detecting the fraud. So that's in high level, which is neural network you're talking about. The system or the network learns from the mistakes or the intrusion activity that takes place in the network. Statistical IDs generate most false positive, that is false alarm. Now it's very obvious, because when you are saying what are general, what are normal, and what are abnormal behaviors, the point is, sometimes it so happens with the changing environment, what was considered to be normal, what was considered to be abnormal becomes normal. In that case, you'll find that many false positive or false alarms the system starts generating without understanding that what type of a traffic behavior is coming. Now, limitations of intrusion detection system, as I made it very clear, this will only generate red flags. They will give you an alert that this type of an activity is taking place. They will not take any action. Now, IDS will not be able to detect application level vulnerabilities. Now, here you will find vulnerabilities, and I have already in the first module explained vulnerabilities and threat. That is the difference between the two. Now, vulnerabilities are internal, whereas threats are external. So to understand that, application which you are using on an operating environment, now these applications, maybe you have developed it or you have purchased from the market, whatever as the case may be, these applications definitely, if you have developed it, will automatically have certain vulnerabilities. So IDS will not be able to detect those vulnerabilities which are internal to the application environment that you are using it. Similarly, IDS will not be able to detect backdoors into the application. Now, backdoors are like that there are certain open ends or the certain areas which normally, we do not consider them to be, vulnerable, but these are the openings through which the traffic or any intrusion activity can enter into the application. IDS will not be able to detect encrypted traffic. If anything which is coming in the form of encrypted, that is, if you use coded, IDS will not be able to detect it. So this is, at this point of time, it is essential that how do we place the intrusion detection system? You can two ways, internet, you have IDS, then you have firewall, and then you have your internal network. Or you may have internet, firewall, IDS, and then you have the internal network. Now, again, where you place the intrusion detection system, it depends on the organization policy, right? Now we have talked about intrusion prevention system. As I have mentioned, IPSS not only detects the attack, but also prevents the intended victim from being affected by the attempts. Now, this is again You can see the images. First one, the lady in the uniform is informing that somebody is trying to enter. But the second one, IPS says that, okay, if you are entering, I am keeping an eye onto it, but if you try to enter, I'll take action. For example, if some malicious activity or intruding activity is taking place, the network might shut down that port, or network might shut down the entire system for a certain period of time. That's the beauty of IPS. Now we move on to the single sign-on. This is like another important aspect which I feel you should know, because some definitely one or two questions again are asked from this section. Now, single sign-on, name itself says that user authentication service, which allows user to use one set of credentials for accessing multiple applications. Now, this is quite easy. It's because if you are accessing multiple applications, each time you remember the password and user ID, which becomes difficult. So a single sign-on facility can be used, right? It is just like your KYC you once get your KYC done, and then that's all the applications are using the same type of thing. It's more or less like that. What are the advantages of single sign-on? You all know that, because now you don't have to sign on multiple times. You can use the same credentials. You don't have to remember multiple passwords and IDs, and that's all. But disadvantages is also that if you forget about if you forget your single password, so this is a multiple point failure, because in that case, all these applications to which you are accessing using single sign-on you will not be able to do it. Now, single sign-on, that is SSO, versus reduced sign-on, that is RSO. In SSO, user has to log in just once for all the application, but in RSO, user can use the same login ID as well as password for logging into the multiple applications, right? So that is, you don't have to use again and again the password. So what happened is that the single point failure of SSO can be reduced by using, or can be directly brought down by using reduced sign-on. Now, the point which definitely there is a question that is a Kerberos. Now, Kerberos is an authentication service for validating services and users in a distributed computing environment. Now, the point is, these are third-party applications which are there for verifying the identity. Now, normally, sometimes within the organization, you will find that the identity can be compromised, or can be leaked, or can be shared. So what we do is that, to ensure the confidentiality and the genuinity of the identification process, we give it to the third party who maintains it on our behalf, so that this identity cannot be compromised. And that's what is called as Kerberos. Now, in distributed computing environment, both user and servers authenticate themselves. Now, if you, as a user, I'm going to authenticate, as well as the server who's going to give me services also authenticate. So you can say that Kerberos is an authentication services, which is a third party maintaining it for authentication of users as well as the servers. Now we have the last section, that's the fire suppression system. It's an important aspect. So, fire suppression system is again a measures for avoiding the, disaster caused by the fire breakout. So you have water-based system, you have dry pipe sprinkling system, you have halon gas system, you have FM200 gas system, aragonite gas system, and CO2 gas system. Now, these are, you should not remember, but, there's no point in remembering, but sometimes one or two questions are asked. So in water-based system, that's W-based system, water always remains in the system's piping. That is the pipe which is running across the building, around the building, or across the building, under the building, will always be filled with the pipe. In dry pipe sprinkling system, that is DPSS, pipes do not have water until an electronic fire alarm activates the water pump to send water into the system. Now, if you're talking about dry pipe sprinkling, you find that the pipes are all empty, water is not used, but if the fire or smoke alarm is generated, then only it activates the switches of the pumping motors, which will pump water into the pipes for handling the situation. Similarly, WBS is more effective and reliable as compared to DPSS. Obviously, when there is something has to get activated and then it starts pumping, it takes time. But when you talk about the water-based system, they're more effective. Now, halogen gas removes oxygen from air and starts the fire. They are not safe for human life, and there should be audible alarm and brief delay before the discharge of halogen gas to permit the time for evacuation. Halogen gas is banned as it adversely affects the ozone layer. Now, the point is, if you talk about, if you suppose that the fire break out in a record room where there are lots of records and lots of assets and things are maintained, and if you start sprinkling water there, you'll find that a lot of damage happens, physical damage, not because of the fire, but because of the water and other type of things which we are using for preventing the fire. So in that case, the other measures are used, and one such measure was a halogen gas, right? But this is very, very dangerous, and it starts affecting the ozone layer of the atmospheric, right? So it's now banned. But what if in case if it is used in any organization, or when it was used earlier, they say that you have to generate enough alarm, you should warn people, and it should only be used in a building where the human life is not there. The next is FM200 gas. It is a colorless and odorless gas. It's safe to be used when people even are present in the building. F200 is an environment friendly. It is commonly used for gaseous fire suppression, right? So another alternative for halogen gas was used is that is FM200. It is safe. So you may find that a question that which of the two gases are safe to be used when people are there around in the building. If there is a fire breakout, so you can say FM200 gas. Now, aragonite gas is a mixture of 50% argon and 90%, 50% of nitrogen. It is used as a gaseous fire suppression agent. It's environment friendly and it's non-toxic. CO2, again, unlike halon, FM2, and aragonite, CO2 is unable to sustain human life. So CO2 installations are permitted where no humans are regularly present, such as unarmed data centers. Like you have lots, huge machines and servers are there. So if a question is asked, which system is safe for human life, we say that FM200 and aragonite gases are safe for human life, and CO2 and halon gases are not safe for human life. So with this, we've come to the end of the fifth module. I hope you find the information, which I have given in this module satisfactorily explains the concepts which are very important as far as module 5 is concerned. And hopefully, I'll try my best to upload the modules 6 various units which are dealing with the technology, especially artificial intelligence, computing environment, machine learning, IoT, and robotics. Till then, I hope and wish you all the very best. Thank you for watching.